Welcome in, everybody, to another episode of my Beginner to Pro Unreal Engine 5 tutorial series. And we're still marching ahead on this interaction UI, but we are finally done with the backend code, and now we can start focusing on the widget code and those interfaces as well. So without further ado, let's get right into it. Alright, so we'll start off with our user widget CCS, and this we just have here for future expansion. There's no real difference between this and the default user widget, but we have this here in case there's certain functionality we want all of our widgets to have that we customly define. And as you can see in that description, just copy that down, and then we'll move on into the functions. And you'll notice that just like with components, things look a little bit different than they do in our typical actor. So we have this native pre-construct, which is essentially begin play for widgets. And then we have our construct function, which happens directly when the widget is being constructed. So again, we want to put all our initialization kind of stuff in native pre-construct so that this way, when we're ready to draw the widget, which happens at construct, all those references and all that good stuff will be all set. And then last but not least, we have native tick, which is essentially just tick, but for the widgets. And for widgets, we don't want to be disabling tick to save on performance because they're drawing every frame anyways, so it won't do us much help, and it'll help us make sure that we're getting the best possible presentation of our widgets. We want everything to look smooth and all that good stuff. And then here in the .cpp, we just have the actual function definitions. And as you can see, all we're doing, as I said, is just calling the parent version. And all this is here just in case we need to expand it in the future. And now we'll move on to our user widget CCS text, which is just going to be a widget template for our plugin that will contain a main text and a subtext that the user can set as they see fit. And as you can see, we have the interface is included, so the text interface. And as I was explaining last time, each different widget is going to have its own interface, and that'll make more sense to you, as always, once we get more into it. And also, don't forget to forward declare the uText block, because that's what the class is in UMG, which is what we call the widget system in Unreal, for the text that we're going to be making. And then we'll drop down to our pre-construct, construct, and native tick. And this is basically just going to be what we had in the last one. They're just going to be calling the parents version. Nothing too interesting. And we'll scroll down a little bit, and now we're getting to the good stuff. So these pass delegates functions are basically the entire way that our UI is going to update itself. So we're going to declare these two delegate types in the interface. And as you remember, we put that on the receiver component. It has its own delegates. And then what we're going to do is we're going to get this function called on us as the widget when we're created and pass in references to the delegates that will be created on the receiver component. And then when the receiver component wants us to update the text or the UI in general, all it has to do is broadcast those delegates and everything will behave properly. As we get to our delegate callbacks, these are the functions that are going to be bound to those delegates. So whenever, if you remember in the receiver comp, we got to a point where we had the delegate and we put dot broadcast because we're subscribed to the delegates, then these functions that are the delegate callbacks are going to be called. So, do you see how powerful that is and how it allows us to update the UI without actually having the UI need to do anything to get that update? And after seeing this valuable information, now would be a great time to like the video and leave a comment if you're appreciating what I'm doing with this tutorial series. These videos take a long time to make, and a like and a comment really helps me out in the YouTube algorithm, so I really appreciate that if you take the time to do it. But anyways, we have our subwidgets here, and this is what it looks like to bind a subwidget to a widget. So see, we have the U property tag, and that looks pretty normal. And then we have that meta equals bind widget. And what that is going to do is when we have our parent blueprint widget, which you'll see next time, we won't be able to compile unless we have a U text block named main text and one named subtext. So we don't have to create this in the constructor like we do for actors, for example, but the widget just won't compile if we haven't created them. And now we move into the .cpp and we get to define all these functions. So as you can see, native construct, we're just calling the parent's version. Well, native pre-construct, sorry. And then in construct, we're hiding the visibility of main text and subtext by default. And the reason for that is we want to make sure that they're hidden until that delegate is called and tells us to put some text on the screen. Because you'll see when we make the widget, just so we can figure out sizing and all that good stuff, we're going to have some placeholder text in there, and we don't want that showing up in-game unnecessarily. And then we'll scroll down a bit, and we have tick is calling the parent's version, and then you can see the notation for binding to the delegate using that delegate function, as I mentioned earlier. So I've already kind of explained what this is doing in terms of binding to the callback, so I'll use this time to explain why this is so valuable to learn to do the UI this way. So it won't really matter now that we're working on a project by ourselves, but when we're working on a big team with artists, there's going to be times where an engineer needs to work on functionality of a UI, and artists need to work on the actual looks of the UI. And how everything will work in an environment where you have source control and all that good stuff is that the artist will check out the actual widget blueprint and make changes to it, and the engineer will be working on functionality on the C++ side. But what's great here is the way that we've set this up, we don't even need access to the widget C++ file to update the functionality, because all that is being done in the receiver component, which artists will have no reason to touch. So basically, it helps to make sure that engineers and artists can work on the same piece of UI, but one person can be working on the looks of it and one person can be working on the functionality, and all that can be done at the same time. I've seen the reverse where basically an artist needs the entire file system and the engineer needs the entire file system, and it just results in people waiting around for other people to get work done, and it just isn't a good environment to develop software quickly and efficiently. And thank you for bearing with me on that rant there. But just remember, when you're designing UI to make it work like this, and you'll save yourself a lot of headaches. But anyways, we'll get to our delegate callbacks now. And first, we're just going to make sure that the new text isn't empty and that the subtext isn't already empty. And if that's the case, we want to hide the widget because we don't have any text to show. That's what that first if statement is doing. And then if we get past there and that return as well, then we need to set the main text block to be the value of the new text. And we need to make both the main text and the subtext visible. So that's what we're doing on the callback. So that's every time we get new text, that's what's going to happen. And then we have the exact same thing happening on the subtext, but opposite. So as you can see, we're checking the new text, but now we're checking to see if the main text is already empty. And then we're doing the same thing down here where we're setting the subtext and setting them all as visible. So yeah, this is how we're going to be updating the look of our UI without having any reference to where this functionality is actually happening. Which again, I can't stress how important this is. So just make sure if you're making UI, make it like this. And then we'll move over to our input icon and we'll paste everything in. So we have the input icon interface in there in the includes. And then also we have our two classes that we're forward declaring. So overlay and image. So other than that, pretty similar to the last one, no big deal. And then we have our pre-construct, construct, and native tick. And those all kind of work the same way as we'll be doing our setup in the construct like we did in the last one. And as you'll see, we'll scroll down and we have the delegate here. And all we're going to be passing in is a fname because we're going to have a list of basically buttons that can be pressed and what images to show for those buttons. So again, we're keeping all the functionality outside of this class and all of the looks kind of stuff is inside of this class. So again, very important. And then we have for our getters, we're getting the valid key, well, whether or not it's a valid key. And that's basically just making sure that we have something to show when we're given the fname from the delegate callback. And then we'll scroll down here into the protected section and we have our delegate callback. And another thing I forgot to mention, you have to tag the callback with the U function macro or else it won't call correctly. So that's also important. I forgot to mention that. But as you can see, we're just passing in that fname in name. And with that, we're going to be able to swap all the images and the visibility on those images. And then below that, we start our widget bindings. And as you can see, we just have a whole bunch of images. So we have the main image and then the icon highlight 1. And that basically is going to show all the assets we made. Oh boy, I guess like maybe 5 lectures ago when we made all those assets in GIMP. That is what's going to be updated, and you're going to be able to see all your hard work in game, which is going to be exciting. And then we'll scroll down a bit more, and all we have are the rest of our highlight bindings. And then we have the actual input icons region, where we'll have the input icon names list. So that's just going to be the list of valid names, and that order is going to matter a lot when we fill it out in Blueprint because it's going to be bound to those input icon main images that you see below. So we're just going to have 2 arrays, one of the names, and basically we're going to find the index of that name and then show the appropriate image based on that index. And then we scroll down a bit here and we have the rest of our highlight images. So same thing here, these images are going to be here to correlate with the actual index that we find. And again, we're going to plug all these in the widget blueprint, and you'll see how that works when we get to that. And then we'll get over to the C++ side, and we have the include for image. And then in native construct, you'll see that we're just going to hide the overall widget by default. And other than that, we're just calling the parent's version in the 3 default widget functions that we declared in the header. And then we'll scroll down a bit and we have our binding function to the delegate. So that works the same as it does in the text widget that we went over earlier. Then we have our get is valid key. And as you can see, the first thing we're doing is trying to find the name. And if the found index equals index none, and that's just a little macro that maps to whatever the value for none is. In this case, it's usually -1, but if you use that macro, then whatever it happens to be for that function, it will automatically map to. And then if we actually can't find the F name, then we need to log an error message to the log letting us know that we couldn't find the F name. And then we want to set the visibility to hidden and return out false. So we'll let the caller know that we weren't able to find that F name. And then we have to make sure that the main image and the first highlight are valid. And the reason we're doing just those two is a lot of key presses will only have one highlight. So for example, our interact key by default is going to be F if you're playing on mouse and key. So we only need to highlight the F key and nothing else. So basically, if we don't have the main image and the first highlight, then we just want to hide the widget and get out of here. But if we do have both of those things, we can continue. And then we'll scroll down a bit to see once we get past those checks, we're going to set the visibility to visible and return true, letting the caller know that this is a valid key and we're ready to swap out the images. And speaking of that, we're going to go down to our delegate callback. And as you can see, the first thing we do is call that valid key function and return out if it isn't valid. And then next, we're going to get the index of the input icon name. And as you can see, we don't need to check it because we already did that in the get is valid key. And then below that, we're going to set the main image and the highlight image. So just those brushes. And that's just the notation for updating the image. So nothing interesting there. And then next, we need to check to see if the second image is valid. And if it is, we set the image. And if not, we just hide it. And then we'll see we're going to do the same thing for the third one and the fourth one as well. And then you'll see we have the fourth one there. So just the exact same thing. And then we're all set. And with that being said, we're going to call it a day for today. So we got a ton done, and we're actually within striking distance of finishing this entire feature in the next video. So that's very exciting. So with all that being said, thank you so much as always for watching, and I'll catch you in the next one. Later.